19. All right, so we have a radical in the denominator, and we need to get rid of that. So let's multiply not by 3 radical 15, but just radical 15. That's all you need to do. What that does is it frees, gets rid of the radical, because this is going to be 3 times radical 15 squared. So that effectively undoes the radical, which breaks it free. So you don't actually have to write anything other than what the radicand is here. Okay, so we know it's going to be over 45, but I don't see any 45 answers. So we've got to probably break this down here. If I look at this, I know that this is 25 times 6. So 25 times 6, that has a pair of 5s in it, so I can take a 5 out, radical 6. Now 5 and 45 can be reduced as a fraction. That's 1 over 9. So radical 6 over 9 is the answer. Keep going here. It's just now I have a binomial in the numerator. There are no pairs inside 14 that would give me anything else, so it looks like I'm going to have that. I do see 2 14s here, so my guess it's one of those. Let's see what happens when I distribute that. It's going to be 2 radical 14. And then 3 times 14 is going to be, what is that, 52. Okay, and let's see, inside 52, what's in 52? Let's see here. Unless, oh, it's 42. Okay, it's 42, and that answer is right there. Okay, now when you get to 21 and 22, this is a little different. This is when you have to multiply by the conjugate. So 3 plus 4 radical 3, 3 plus 4 radical 3. Do not change the 3 in the denominator. Just keep him the same, but you do want to change the middle part, because that is going to allow you to break the, to get rid of the radicals. So you're going to get 9, and then the middle terms actually cancel out. So you get 9 minus 16 times 3. Okay, that's going to give you 9 minus 16 times 3. 16 times 3 is 48. And then 9 minus that is going to be 30. 9 minus that is a 39. So negative 39. Okay, so now we've got negative 39 down here. We're going to distribute this so that we get 9 plus 12 radical 3. So 3 multiplies to the 4, but not this guy, because he is not in radical form. So that's it. So let's see, we got 9 plus 12 radical 3. Now you might be wondering, why do I not see my answer? Well, all 3 of these terms can be divided by 3. In fact, we can divide it by negative 3. So a rule of thumb is to not have the denominator negative either. Always have it out in the front. So we're going to divide everything by negative 3, so that we get negative 3 minus 4 radical 3. He's not going to be touched, but this guy's going to go to 13. Okay, and that is D. Alright, so this guy here, we're going to leave it negative 2 minus 5 radical 3. Negative 2 minus 5 radical 3 equals, now we've got a binomial times a binomial, so these guys can get pretty long, so I'm going to make this kind of small. Okay, minus 20 radical 3 plus 2 radical 3. Those guys actually combined, that's lucky. Doesn't always happen. Then I'm going to get plus 5 times radical 3 squared, which is just 3, so that's going to be 15. Then I'm going to multiply these guys, that's 4, and then the middle terms cancel out, so I'm going to get a minus 25 times 3, which is 75. So what is 4 minus 75 is negative 71. Okay, now I see that. Now this is probably what's going to happen, but let's see what happens. Negative, that's going to be 7. Those guys will be negative 18 radical 3. But like we said, we actually have to divide by a negative because you can't have this guy stay negative. So he'll become negative up there. the 18 radical 3 will become positive, and then that 71 becomes positive. So if this guy's negative, make sure you switch everybody's sign, and we're all set. So the final answer is right here. Okay. Got some graphing. These guys are pretty easy. We know that it's this basic shape where wherever we go, we find our new origin. We move over 1, we go up 1. And when we go over 4, we go up 2. Okay? That's the pattern. But when we get up to over here, you'll notice that we're going to start at a new location. But that 4 tells us when we move over, we're going to go up 4. And when we move over 4, we should have went up 2, but now we're going to go up 8 because we got to quadruple that distance. So quadruple that distance for a 4, quadruple that distance for an 8. Okay? So he's going to go up. So our new location, this tells us to go to the left 3 and down 4. Left 3, down 4, he's right there. 1, 1, 4, 2. And if you want, you could go 9, 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can, so we'll go up 3. So this curve will go right like that, and we're all set. This guy, there's no left or right movement at all because there's no other number on the inside of the radical. So we are just going to go down 5. So we are going to go right here, and now we're going to go that pattern over 1, but we're going to go up 4. That 4 multiplier tells that distance needs to be quadrupled. So now when I go to 4, I'm going to go up 8. So that'll be 1, 2, 3, 4, 5, 6, 7, 8. That's totally sufficient. And there's our answer. Okay. All right. So now we are not moving to the right or the left at all. So we will start at 0, 0. But the negative 3 tells me that I'm going to go downwards. So if I were to go 1, 1, that multiplier tells me to go negative direction. So I will go down 3. And then if I go over 4, I'm supposed to go down 2, but I need to triple that distance for a 6. Alright, so there's my hook there. Okay, same basic procedure here. We're going to move over to the left 3, down 2. This is a positive 3, so when I move over 1, I will go up 3. When I move over 4, instead of 2, I will go up 6. And if I move over 9, I would go up 9. So 1, 2, 3, 4, 5, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this fourth point probably is unnecessary. 3 is sufficient, but that is good. Okay. Alright, these equations here, looks like we're going to have to get that radical by itself. Don't overthink it. It's very easy to get rid of a radical. He just needs to be isolated. So get this guy out of the way. So we're going to add a positive 1 to both sides. So that will now be 8 equals radical 65n minus 1. We're ready to square it so that now I can get rid of the radical. It's that easy. Don't overcomplicate it. Okay, square both sides. That's all. Now the radical is free. Now we got to get n by itself. Move that over here so that we get a 65 equals 65n. And if we divide both sides by 65, we will get n equals 1. Let's make sure that 1 works. Square root, yep, okay, that actually works, so we are good. Okay, now we do not have the radical by itself for us to square. We got to get rid of this guy. He is attached by multiplication, so I will divide. That actually gives me 7. So that 7 equals the radical 7m plus 7. Let's square both sides. Now the radical is free, so I get 49 equals 7m plus 7. Over here, 7, that's going to be 42. Divide by 7, m equals 6. So let's make sure that we don't get the square root of a negative number here. 642 plus 49, 7, that is correct. So answer is B. Okay, we've got to get rid of this 3 here. It is attached by addition, so we will subtract it. Subtracting a negative number makes it positive. Okay, we'll square both sides. So we get 16 equals 8r. Divide by 8, and we get r equals 2. 8 times 2 is 4. 4 plus negative 3 is 1. Okay, so 2 is the answer. All right. Both radicals are all by themselves, so just square both sides. It's perfect. Okay, and I do have to say that if we were to put a +1 here, you wouldn't believe how complicated that problem gets. That's for a pre-calc class, but that gets really interesting just by adding one number. Yeah, that's how it works. I've never seen that on the SAT though. Okay, so now let's get the p's over to one side. So let's subtract 4p from both sides. Okay, and then we're going to add 1 to both sides. +2, so p equals -1. Will -1 cause a problem? -1. Did I get... Actually, wait, I don't know why I got... I don't know why it's negative. It should be +1. +1, 6 minus square root of 5, square root of 5. Yes, square root of 5 equals square root of 5. There we go. Okay, here's where things get a little bit fishier. When you do square both sides, you do have a p squared. So don't worry about it. Just know that you're going to have a quadratic. It's no big deal. You've solved these hundreds of times before, but you're resisting how easy it is. You have a quadratic. It's no big deal. Just move all of these over to the other side so it equals 0. So now the 6p becomes positive over on the other side, and 16 becomes negative. Now this is just the x method. Don't make a big deal out of it. You're looking for factors of -16 that add up to 6. And that is going to be 8 and -2. So p plus 8 and p minus 2 have to equal 0. So you get p equals -8 and +2. That's it. Those are your two answers. So I do not see them here. My guess is one of them doesn't work. So when I plug in a -8 here, you'll notice that p is, you can't have a square root equaling a -8. I'm ignoring the square here. If I took a square root, I cannot equal -8. So the -8 has got to go. All right. So our only answer is actually 2. Okay. 16 minus 12 is 4. Square root of 4 is 2. So that actually does work. Okay, now we got the radical by itself. We will square both sides, and now we get r squared equals 4r. Okay, well, it's just a quadratic. Set it equal to 0. Move that 4r over to the other side. Now there is no c, but that's okay. Just factor out an r. You've done that before. Just take an r out, and you can see that my two answers are going to be 0 and +4. Let's see if both work. 0, taking the square root of 0 is 0. 4, 16, yep, taking the square root of 16 is 4. So both of these guys work. My answer is A. Okay, now this is just about function notation. We just take the 1 here and plug it into an f. Now what is the f function? The f says wherever there's an x, I'm going to replace it with a 1. 2 times 2 to the 1 plus 1. All right, and just figure out what that is. That's 2 times 2 to the second. Make sure you do the order of operations. That's going to equal 8. Same thing here. -2 gets plugged into both instances of a. So notice that I'm putting in parentheses. Okay, remember parentheses is the key to functions. Okay, because -2 times -2 is +4, and that would be a +6. So your answer is 10.